My name is Tommaso Radicioni, and I'm a PhD candidate in data science at Scuola Normale Superiore, and I'm still School for Advanced Studies in Lucca. In this presentation, I'm going to talk about my PhD work, a network-based and data-driven study on Italian Twitter thread discussions. Before starting, I would like to thank my two supervisors, Tiziano Squartini and Fabio Saracco, who are the co-authors of the present research project. Nowadays, social media platforms as Twitter play a major political role within the variegated media landscape. Citizens who use social media on a daily basis have significantly increased, and social media have become increasingly central during political events, such as electoral campaigns and societal discussions, contributing to polarization process. The massive amount of data offered by social media platforms needs to be filtered out to select only relevant information out of this data deluge. For these reasons, we implemented an entropy-based framework for extracting relevant social and semantic information out of two distinct conversations on political and societal nature in the Italian Twitter sphere. The first one consists of 1 million tweets retrieved during the discussion in the run-up of the 2018 Italian election and during the 2 weeks after election day. The second one consists of 5 million tweets retrieved during the discussions on Twitter about the issue of migration during the period May-November 2019. While an increasing number of studies unveiled important aspects of social media interaction, such as the online user segregation in echo chambers, little attention has been given to the study of social media contents and how their diffusion contributes in building a collective political activity. To combine the behavioral and the semantic aspects of online political debates, our analysis consists in a two-step procedure. First of all, we define the scarcity communities as groups of Twitter users which share similar retweeting patterns. The scarcity communities are extracted from the bipartite network of non-verified users who retweet verified users. From this bipartite network, we infer the one-mode projection on the verified users layer. Then, non-verified users are assigned to each verified user's communities on the basis of their polarization inferred by their retweeting activity towards each specific community. Once the scarcity communities are obtained, the corresponding semantic network are built by considering the concurrencies of hashtags that are present in the tweets sent by its members. Semantic networks are then obtained from the one-mode projection on the hashtags layer of the bipartite network of users and hashtags. The concept of similarity is based for both bipartite networks on the statistical significance of the number of shared links between nodes of the same layer with respect to a benchmark model. In particular, in the case of user hashtag bipartite networks, each couple of hashtags is linked if their number of users tweeting or retweeting them is statistically significant, while in the case of user bipartite networks, two verified accounts are connected if their number of non-verified users retweeting their messages is statistically significant. Extracting relevant information from the retweeting activity of non-verified users and from hashtag concurrencies in tweets is the crucial aspect of our procedure. The one-mode projection of a bipartite network could be performed in several ways. The naive projection consists in linking any two nodes, alpha and beta, if their number of common neighbors is positive. In order to obtain a stricter one-mode projection, our approach consists of measuring the degree of similarity of nodes by counting the number of common neighbors. Then, the statistically validated projections are extracted by quantifying the statistical significance of the degree of similarity of nodes alpha and beta through a benchmark model. In other words, the empirical number of times any couple of nodes are connected is compared with the outcome of a null model. In our analysis, we use a mathematical framework which is defined within the exponential random graph formalism, an approach consisting in a constraint maximization of Shannon entropy. Three benchmark models are defined by constraints which are satisfied on average in the final ensemble. Stronger constraints correspond to stricter benchmark models. Here are reported the three null models employed in our research project. The bipartite configuration model constrains the degree of nodes belonging to both layers, and it is used both for the verified users communities and the semantic network extraction. Instead, the bipartite partial configuration model and the bipartite random graph model are used solely for the semantic network's extraction and constrain respectively the degrees of nodes belonging to a single layer and the total number of links. Here, in this picture, you can see a diagram of the aforementioned procedure for the World Trade Web, which is the network of trade relationships between countries in the world. The real-world network is here compared with BCM ensemble, and observed values are compared with those assessed using the probability distribution obtained from the BCM. The computation of the statistical significance of the similarity measure between nodes alpha and beta consists in calculating a p-value, namely the probability of observing a number of b-motifs greater than or equal to the observed value. Once the statistical significance of the similarity between each pair of nodes is quantified, only those pairs whose p-value is statistically significant must be retained. To this aim, a validation procedure for testing simultaneously multiple hypotheses is needed. The choice of this work has been directed toward the false discovery rate, also called FDR. In this picture, you can see the one-mode projection on the layers of country in the World Trade Network. As you can see here, the BCM allows the detection of models of countries that have similar industrial systems. As a first result of our analysis, our main finding is the identification of a behavior-driven rather than ideological determined feature of discursive communities. Although these communities do not necessarily match the political orientation of their users, the adopted procedure allows for the detection of political coalitions through the lens of conversational dynamics. In this picture, for sake of simplicity, only the groups of verified users are shown. In both datasets, and so in both pictures, you can see the main visible communities are the yellow one, representing the five-star movement users and supporters, the green one, the far-right-leaning users and supporters, and the purple one, which is a mixed community of media, ONG, and minor party users. Then there is even the red one, which is the center-left leaning users and supporters. On the side of the semantic networks analysis, instead, one of the main findings concerned the observation that the K-shelf decomposition of the naive semantic networks revealed the presence of a core periphery structure, namely a bunch of very well-connected vertices linked to a group of low-degree, loosely interlinked nodes. As shown in the right figure, the network core is composed by the main thematic hashtags and have an internal substructure with few hashtags which act as bridges between subcommunities. Moreover, this core periphery structure is validated by comparing the nodes of the innermost K-shell with the core obtained by employing an algorithm of core periphery structure finding based on bimodular surprise. In the left figure, we can observe the naive semantic networks with all the periphery hashtags which represents the secondary keywords. It represented in blue, light blue, and orange. Another relevant result is represented by the statistically validated semantic networks, which provide important information of the most debated topics within each discursive communities and characterizing the communication strategy of the corresponding political party. For instance, the validated monopartite projection acts as a filtered version of the naive projection on the bottom right, by selecting only relevant thematic hashtags which survive in the one-mode projection. In conclusion, the present work provides important insights on the analysis of social and semantic dynamics of Twitter political discussions. First of all, the adopted procedure is a methodological advance per se. The extraction of discursive communities and semantic networks relies on Shannon entropy maximization under certain constraints, which is an unbiased procedure and a method able to extract political information without any prior information on the system. Then, particularly insightful is the analysis of semantic networks at the mesoscale. What emerges is the presence of a core of topics, namely a densely connected bulk of hashtags, surrounded by a periphery or loosely interconnected subtopics. Finally, null models validation techniques shows a diversification of discursive communities in terms of semantic features and topics. I hope you enjoyed my presentation. If you have any question, I'm here to answer in the Q&A session. Thank you for your attention.